New card-based scheme to ensure security and trust in vehicular communications. Irshad Ahmed Samra. Saudi International Electronics, Communications and Photonics Conference, SAIC. April the 24th to the 26th, 2011. Introduction. Authentication requirement in VANET. Related work. Trusted security module in VANET. Proposed card-based scheme. Conclusion. References. Q&A. Overview. Vehicular ad hoc network is a special kind of network in which nodes, vehicles, can communicate with each other on the road and with its infrastructure. VANET applications. Safety applications. Non-safety applications. VANET security requirement. Authentication. Integrity. Confidentiality. Availability. VANET user requirement. Security. Privacy. Trust. Trust. An entity can be trusted if it always behaves in the expected manner for intended purpose. All components of the network, vehicles and infrastructure, are behaving in an secure communication between the components, and serve the users and save human lives. Authentication requirement in VANET. Authentication is an open issue and key security requirement in vehicular network, and all applications are required to be authenticated. Authentication is needed for most tasks, for sending critical messages to other vehicle or getting some services from the network. Authentication is required in two different cases. If users send or receive safety messages in network, it should be authenticated first by a valid user. When user needs any service from service providers, SP, they should check the user information from its own billing server, which later charges the users for the use of any sort of services, resources, related work. Authentications types in VANET. Message authentication. Broadcast message authentication. Pairwise message authentication. Group-wise message authentication. Vehicle authentication. Roadside unit, RSU, authentication. Authentication requirement for business transaction. Prepaid package, pay before use. Postpaid package, use after pay. Trusted security module. Trusted platform module, TPM, is a hardware chip, and it is the core component of the Trusted Computing Group, TCG. TPM provides cryptographic functions, secures storage of secret data, and provides the basis to fulfill major security requirements. TPM functionalities. Low cost. TPM is a low-cost security module as compared to tamper-proof device, TPD. Resists software attacks. TPM can resist software attacks, but it cannot control hardware tampering. Ownership. TPM_take ownership command creates ownership of the vehicle. Whenever user buys new vehicle, the authority will assign it to be the owner of that particular vehicle. When the vehicle is sold out, then we need to change ownership to the new user. Cryptographic functions. TPM provides cryptographic function and also ensures the data integrity in the network through cryptographic components, SHA-1 engine, RSA and random number generator. Root of trust. Root of trust for measurement, RTM. Root of trust for reporting, RTR. Root of trust for storage, RTS. Proposed card-based scheme. Authentication is more complex task in vehicular network compared to any fixed network due to dynamic nature of its topology. Our scheme is based on fixed infrastructure, which is called Vehicular Service Providers, VSP. VSPs use secret cards with different time durations like 1 month, 2 month, and 6 month. when the users need to do is only to enter a 16-digit secret code into the vehicle unit and then communicate with Vehicular Service Provider's server. The VSP server will verify the secret code through an integrity verification process, and after verification has been completed, it will activate the PCA at the user vehicle to generate certificates for some specific time duration. Objective of this proposed scheme to solve the problem of authentication, and users should be authentic while they join network on road and taking services. 16-digit secret code. First 8-digit uses for PCA is taken from a smart card inserted to the vehicle unit. By this way, we eliminate the need for connecting with the PCA and sending request for certificate and key for singing the messages. In this scenario, a vehicle A signs a message with TPM signing, SK, key, attach valid AKE certificate and signature inside the VPS security tag and broadcast this message to other vehicles. Every other vehicle checks this message that comes with security VPS tag. If VPS tag is exist with message, it means this message is secure and properly signs with TPM signing key, SK. Every time TPM generates one signing key and sends request to storage area for AKE certificate. By frequently changing the signing key and AKE, it maintains the security in the system. Secure communication. Shows the authentic warning message with security tag. Because of the VPS signature certificate, it can be seen that it would be difficult for an attacker to change the security tag. Shows how an ideal secure and trusted communication between the vehicles would take place using the proposed scheme. Secure business communication. Next 8-digit secret codes is used for business-related applications such as taking some services and paying money for these services like telephone and internet services on road. Vehicle A sends request for internet access on road, so authentication and billing server authenticates the user together with its billing information. After that, the VPS server gathers some more parameters such as speed, position and direction of the requesting vehicle. If the user of the vehicle fulfills all requirements, the VSP server provides required road services. Another vehicle C may also sends request for any other services, and the same procedure will be followed for serving the required services. Unique features of proposed scheme. It is based on card which has 16-digit secret code that provides security based on Trusted Platform Module, TPM, for signing safety messages and for business transactions. The storage area is proposed inside vehicle for saving security keys and billing information. It eliminates the dependency on external storage device memory stick that should not use for the storage of users' information. Users do not depend on external party for authentication in dynamic topology vehicular communication network. Message tag contains signature and certificate that make difficult for attackers to alter the tag. Proposed scheme is based on TPM and it is low-cost security device and develop the chain of trust in vehicular network. Conclusion. Security and trust are two main users' requirements for trusted vehicular network. In vehicular communications, when user receives any safety message, it should be authentic, and that the requesting source is valid. In vehicular communications, when user receives any safety message or non-safety message, it should be authentic. Authentication is required for sending and messages and also for business transaction. Proposed scheme are based on TPM and provides user authentication requirement in network while communicating with other vehicle and also taking service from many service providers. We hope proposed scheme will be helpful for solving the problem of authentication in high-speed vehicular environment. Please download this research papers from ResearchGate and Google Scholar. Please share this video and subscribe the VANET channel, and don't forget to view the series of VANET videos. If you have any question, then email at the given email id. Thank you very much for watching this video. Goodbye.